base, e, and natural logarithms. All right, so what we're going to work on today is you're going to evaluate expressions, solve equations, and utilize properties involving natural base and natural logs. So really what you're doing here is just adding like another special notation. Special notation. Okay, so what is base e? What is natural logs? Okay, first off, you know pi. 3.14 dot 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 whatever. Square root of 2 is like 1.4 dot 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 dot. I don't even remember beyond that. Okay, these are all like irrational special numbers. Okay, pi is a number. Even though it's got that funky symbol, it is a number. Okay, e is called, or it has been called, it was called the natural number, but now the book wants to call it the natural base. Whatever. Either way, it is a number that represents 2.7182.8 dot 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 dot. It is like pi. It goes on forever, never, never. It will never repeat. It will never, never. It will never end. Okay, so it goes on forever. So 2.71, 2.718, whatever. That however you want to remember. E is a natural number. So every time you see now the letter E, you have to assume that is, or you have to go with that's a number. There's a reason why you never see us use E as a variable. Okay, so this again, like I said, is called the natural base now instead of the natural number for whatever crazy reason that somebody thought it was a good reason. Okay, so let's start off with just like we did logs. How can you write from exponential form to log form? Well, remember, base, exponent, answer. So log base e of 8 equals x. Now here's the thing. When we deal with log base e, we don't actually like to use log base e. Just like when you don't see a base, you assume it's log base 10. Log base e, we actually use a different symbolic notation. We use ln. So ln is now in place of log base e, which means the natural log, hence the reason ln. Why it's ln and not nl? No clue. But you get the idea. So every time we want to deal with e, you will use ln instead of log base e. So e to the 5th equals x means ln of x, log base e, or the natural log, I'm sorry, I should actually say natural log. The natural log of x is equal to 5. How about going the other way? Well, let's go the other way and write it in exponential form. So notice here, you'll see ln, and so when you see ln, you have to go with that is base e. So then we say e to the, or x is equal to, approximately equal to, because it's of course an approximation, e to the 0.7741 power. Okay, notice here that it does, like I'm trying to keep the variables on the left and numbers on the right. ln 10 of x could be 10 equal to e to the x power. So you can see here how we can work these. No biggie, all done. There you go. So, how can I use my properties? Well, let's use the properties. Let's try to get this down to one, like a singular. Let's condense this down to one logarithm. So, same properties. Okay, I see a number in front. That means I can move that back inside, become an exponent. So now I'm saying ln of 10, the natural log of 10 to the 3rd power, minus the natural log of 8. Well, what can you do with a minus? You can divide. So natural log of 10 to the 3rd power, which is 1,000. Almost forgot that other 0. Divided by 8. What's 1,000 divided by 8? Well, that's 125. In all honesty, if you got there, I would be happy. But I'm looking at an example from the book, and they wanted you to realize, ooh, that can be written as 5 to the 3rd power, which means I could rewrite it as 3 to the natural log of 5. What I'll probably do is this. You get here, full credit. You get here, extra credit. Yay. Let's put a smiley face. Yay. Okay, so kind of think of it like that. By the way, if you show me the smiley face, I'll add a point to your next test. Or I'll add some points. So you got to show me the smiley face. Alright. So here's another example. Now this one, ln of 8 to the 6th power. So the natural log of 8 to the 6th power minus log. Same thing. Notice how I'm using the powers to bring them inside. Then I can put them together and divide. Notice you got to take care of the exponents before you can take care of the divide. And then you can come up with the answer. Now, I did actually type that into the calculator. 8 to the 6 divided by 4 squared. You get 16,284, which actually comes out to something like, and again, I would be happy with that answer. Natural log of 4 to the 7th power. Okay, so again, I would be happy with those. You're fine. All right, so now let's do some solving. Okay, so same idea. Here's where we're using this idea of algebra. Think of this as like a variable here. You need to isolate it. So how do I get rid of the times 4 and the minus 5? Because this is an exponent. It's not a logarithmic equation. Well, let's add 5 to both sides. Get 8. Then how do I get rid of that 4? Let's divide. And then you have 2. Now, here's the fourth property that we didn't see much of the other day. To get rid of the e, I need to take the natural log on both sides. There is a property that says if you take the log of that number that it is, in other words, since I'm saying log base e of e, because that's what a natural log is, the e and the natural log cancel each other out, leaving me just the 2x, or the negative 2x. Technically, I should have moved that to the front, but I'm being lazy. So you get the idea. But the e and the natural log will cancel each other out. But I'm still left with that natural log of 2, which is a number you can find on the calculator. So now I need to divide by negative 2, and that would give me my final answer. Okay, so you kind of get the idea. Oopsie, there we go. So you kind of get the idea. So here, notice, this is just some normal steps of, say, solving that you've seen before. So here's another example. Maybe pause me and see if you can figure this one out on your own. Watch the steps. I'm going to let it play. So you can see that I will add 12, divide by 3, then I can take the natural log and get rid of the e in the natural log and left with 4x. Find out what the natural log of 9 is and divide it by 4, and I will have my final answer. Your final answer should be approximately x is equal to 0.549 thousandths. Something like that. So 0.549. Anyways, all right, let's look at another problem. One more example, and then I'm pretty much done. Yay! Okay, so now, what happens when I have a natural log? Okay, let's see if we can rewrite it in exponential form. But again, to get into exponential form, we need everything inside the logarithm on that one side, on the left side. So now I'm going to say natural log, or I'm going to divide by 3. Oh, I could have divided by 3. Oh my goodness, I'm so slow today. Okay, so let's see if I can get rid of it sometimes. That helps too. So natural log of 4x is equal to 24 divided by 3, which is 8. Now, there's a property that says if I put both of those like as e, both of them as exponents of e, the natural log and the e will cancel each other out, leaving me with 4x equal to whatever e to the 8th is. Then I can divide by 4, and I can get my answer, which in this case is about 745 and 2,395 10,000ths. Yeah, I made that a funny number. So you kind of get the idea. Again, this is one of those we will work on like in class, probably maybe even spend a day or two trying to make sure y'all get enough examples and you understand. And that way you're better prepared for a quiz, because we will have a quiz. Why not? Anyways, that's it for today. Thank you so much. Y'all take care.